Hello everybody and welcome to my YouTube channel. My name is Tayyib and I'm a PhD student here at King Abdullah University of Science and Technology, KAUST. I'm doing a PhD in mechanical engineering and I have a podcast on campus called Convos on Campus where I interview interesting people around campus, interview my colleagues, professors and employees here in KAUST. Stay tuned for entertainment, insightful information, and a lot about KAUST lifestyle and Saudi lifestyle in general. I hope you like the content and stay strong. Thank you. Okay, let's start. Yes. Hello, everybody, and welcome back to Convos on Campus, where we meet some of the most interesting people on campus. Today, we have a very special guest. He's from Brazil, right?
Yes.
And also Italy.
Yeah, I have both nationalities, yeah.
Right. How about you introduce yourself to the audience?
Yeah, so first of all, thanks for the invitation, Taib. Very nice of you. And I really appreciate your project here in campus, giving visibility for all the amazing people that we have here.
Thank you.
And so my name is Otavio. I am 31 years old. I come from Brazil. I am a last year PhD student in the electrical and computer engineering program with Professor Shehab Ahmed.
Mm-hmm.
And I have been in KAUST for more than 6 years now. I did also my master's with Professor Shehab. And I'm very happy to be working towards the completion of my PhD and trying to work out my research.
Great. Okay. So, so you did your master's here?
Yes, correct. Yeah. So I did my master's here. I joined in January 2019. And my master's was more on the topic of wind energy conversion for delivery to high voltage DC direct current connections.
Okay.
And then for my PhD, I not properly switched topics, but just steered it a bit more on a more high level view, a system view of power systems with high participation of renewable energies.
Okay.
Yeah.
Lots of big words there.
Yeah. Yeah.
So you would sum it up as in you're working on solar panels?
I don't work at the panels from a
Themselves?
device level. So I try to understand how the energy coming from solar panels and injected in the system through power electronics interfere with the behavior of the system when compared with traditional power systems that we have been used to for around 100 years, right? Where we have power systems that are highly reliant on big power plants, where these power plants use usually a heat source or, for example, hydropower, which is very common in Brazil.
Hydro meaning like
from
oil.
No, hydro from water, right?
From water, hydro.
We usually have a large storage of water. Usually you put some restriction on a river, you build up water pressure, and then this water flows through a turbine that generates a big generator, which is basically a heavy rotating machine. And we know from the laws of mechanics, right, that we have inertia on when you have something with mass rotating or moving. It opposes the change in speed. And although this is a mechanical property, this is a property that is also reflected on the electrical side of things in the sense of making the system more robust and resilient to changes, for example, in the energy consumption. So, for example, if we have the turn on of a pretty big industry, this is a big power demand, and the first response of big generators would be to slow down because it is as if you're trying to hold the shaft, right? You're applying a load to the shaft. So this is a very positive property in traditional power systems, and it is a property that we end up losing in more modern power systems where we have lots of energy sources that are connected to the system through power electronics, because power electronics have zero inertia on their own, and they also have some different electrical properties. They are a bit more sensitive to big currents, big swings in voltage, and all these things that generators handle pretty well. making the system remain stable and operating fine under large disturbances such as short circuits if we lose a line and things like that.
Okay, cool. So how would you explain your research to a kid that is 5 years old?
I would say that imagine that you have a remote controlled toy car, right? And this car can run too fast, too slow, steer in the wrong direction, or even crash or stop working if you don't press the certain combination of numbers in the remote control, right? And basically, what I'm trying to do is figure out what is the best combination of buttons that we can press in
Optimize.
to optimize, but also like to decide on the best actions on power systems that have different types of generations, right? This is what we call mixed generation power systems. So if we extrapolate this example of the toy car to a large system, which is maybe a city or even a whole country, the power system of a whole country, we are trying to understand how the combinations of different energy sources impact on how the system operates, and therefore what are the best actions to make sure that throughout the energy transition, we can ensure that the system will remain operating reliably and safely, even when we have high levels of renewable energy.
Okay.
Yeah.
It's a bit elaborate for a 5-year-old, but
I mean,
these days
I jumped from the car to the system, right? But the whole idea is this. So we have the the car has many moving parts and complexities of its own. And basically what we use to manipulate the behavior of the car is our decisions on the remote control. And this is basically what we do in the power system. The power system has a lot of moving parts. You have the behavior of people that influences how much power is being consumed. The economical development of the country dictates how many new industries are going to be opening and how this changes as well. And behind power systems, there are a lot of very skilled people that work on the control rooms 24 hours a day, looking to see if everything is working and if they need to press any other combination of controls to keep everything running, right?
When you say power systems, these are the systems that distribute electrical power, right?
Yes. So basically, we usually categorize power systems into 3 layers. The first one is the generation layer. So this is when we talk about, in classical power systems, we talk about the big power plants, right? Either a coal power plant or a gas power plant. This concept has changed a little bit in new power systems because we have many people having solar panels in their houses. We have more distributed generation, right? And then we have the transmission system. These are the big transmission lines that we see around when you drive through the road. And then we have the distribution systems. This is when these big transmission lines arrive to a city or arrive to KAUST, for example, and then you have power being distributed at much lower voltage levels. So this is so usually I work in the generation and transmission level, because distribution level is a whole other complexity to be worked on.
It's a whole different challenge.
It's a whole different challenge, correct?
Okay. Yeah, it's like a network.
Correct.
So it's like an octopus trying to reach its tentacles and provide electricity.
Correct. Yeah, if we talk about if we do the analogy to networks, we usually have the generation and the loads would be nodes in a network, and the transmission lines would be the edges connecting.
The edges.
Connecting these nodes, right? And then if we go to a node where we have a load, we can expand this further into the distribution system.
Right.
It is as if like it is a sub network that has its own behavior. But if we abstract to the transmission level, we can model it simpler as a load.
Yep. Okay. All right. If you were not, I'm not sure, like, if you were not in research, what would you be doing as a career? Like, it seems that you're very passionate about this, right?
Yeah, like, I mean, I really like the topic, for sure. I have been working, dedicating the last 5 years of my life to this, and I became very passionate because it is also a hot topic, right? Everyone is talking about energy transmission, energy transition, and trying to understand how everything is going to work in the future. And there's lots of new technologies that revolve about this energy transition, and I'm just trying to give a small contribution to that. But I think that if I had to work on something else, probably wouldn't be so far away from research in some sense, but I really believe in the power of education. So I think I would work in education, most probably higher education, either undergrad or above, because I think that this is the moving force of any nation that wants to go forward and make an impact. Because through education we
Progress.
create new skilled professionals and even researchers, right? So it is a process, and education is the beginning of this process. If education itself is disrupted somehow by not having good teachers or even like inspiring teachers, you start losing this interest of people of looking for something more, right? So education is for sure one of the things that I would go for. But I also like have this deep passion since I was a kid for diplomacy and politics as well. I like dealing with people and understanding people's feelings and their interests and how these things can come together. Specifically in diplomacy, after going abroad from Brazil, this is actually the third time that I live abroad. I really like this idea of like representing your country and interacting with different cultures. This is very fascinating to me.
Okay. How's your experience in Saudi so far?
Very
You've been
good.
here since when?
Since January 2019. Yeah. So Saudi Arabia has been very generous to me, both in KAUST and outside. I have been exploring Saudi mostly for diving. I can't say that I have been going to the mountains to camp. It's not really my cup of tea. I really like being close to the sea. So I have explored Yambo and Umuluj, also Olith to
Okay.
to
Yeah, you've been
dive.
around. Yeah.
Yeah. I go pretty often to Rabigh, Jeddah to dive. I have been recently to Riyadh for my third time, and it was the first time that I tried their public transportation system. Fantastic!
That's amazing,
The
huh?
new metro is incredible, and I was so happy to see that so many people are using it. I think that this is such a massive step.
Yeah,
Um,
it's amazing.
yes, I also I think my first year in KAUST, I also had the opportunity to visit Itra in
In Eastern region.
yes,
In
correct.
Dhahran.
Yes, in Tehran
Mm.
was also very, very interesting. So yeah, I got very good experiences from Saudi. Saudi people are very, very generous, very helpful, very friendly. They are still today. Sometimes I go to the more traditional areas, such as like Al Balad, and people come and ask where I'm from, and welcome to Saudi. This is a very warm, welcoming behavior. Yeah.
Yeah. No, Saudi is heading in a really good direction.
Yes.
Yeah.
Yeah.
And we are really fortunate to be at this time and this place with this much development happening, right?
Yeah. This is true. I think that we not only us that are foreigners, but you as Saudi citizens, you have the opportunity to see uh, transformations happening in real time. Like you're seeing like history developing in front of you, and some things are happening so fast. I mean, I've been here for 6 years, and I can definitely tell how many changes I've seen in the past
Yeah,
year.
it's exponential.
And my guess, when I look at this, at least from my perspective, these changes are moving in the right direction, and it's very good. Because when well, things that have been working a certain way for a very, very long time, first you have usually the inertia, right? You have the inertia also in
Resistance.
changes. You have the resistance. So you have things that have been moving at that speed, at that way for a very long time, and changing usually requires some driving force, and you can't always tell if it's moving in the right direction. But I think that Saudi is. Yeah.
Yeah. No, alhamdulillah.
Yeah.
Sweet. Even though I'm not Saudi.
You're not
And
Saudi.
I'm Jordanian.
You're
close
Jordanian.
by.
Oh,
Yeah,
I didn't know, but
yeah.
yeah, but
But I'm very
I
proud and happy to see the
Jordan is
advancement.
definitely a place that I need to visit before I
Oh, you
leave.
haven't?
No, I have.
Okay.
Yeah, yeah,
Yeah. It's a very short trip from here, 2
yeah.
hours.
Okay,
Yeah, yeah.
yeah.
You go
By
to
plane.
Petra. Yeah, by plane. Petra, you go to Dead Sea.
Yeah,
Yeah.
yeah, yeah.
Okay.
Nice.
All right. What's one habit you think every student should develop?
I think that this is not only for students. I guess I think that everyone should go for this is to become passionate about learning instead of becoming passionate about knowledge, because learning is a process and it is the precursor of knowledge, right? If you know how to learn, you are going to acquire some knowledge, and learning is actually a very strong exercise of humility, because you're
Mm.
all the time like asking yourself whether you know that or not, or if you know that enough or not, and at the same time that you recognize what is the background that you lack, you are looking for the people who have that background, and you have the humility of asking them to teach you.
Hmm.
So I think that this is very important. On the other hand, if you're just passionate about knowledge, you tend to get stuck on what you already know, and then you settle on that like comfort zone.
Comfort zone, yeah.
So I think that curiosity should always come before certainty about things. Yeah.
Okay, so learning.
Yes.
Mm.
Yeah, and about anything, right? And I think, especially for the people from KAUST who are watching this, I think that we are in such a unique place to exercise learning, because you can learn from your professors, you can learn from your postdocs. We have a huge community of people that work in the most various research fields possible. So um, you'll only be gaining if you sit down 5 minutes with your colleague that from a completely different area and say, hey, what do you work with,
Mhm.
right? And learn a little bit about what they do. So I think that this is a great thing that people should take for whatever they do, like prioritize learning than settling for what you already know.
Yeah, even in daily life,
Correct.
you should
Yes.
you should always keep on learning something new.
Yes,
I never
exactly.
knew how to, do a podcast. I just learned it on the fly.
Exactly. And
And
you dove right at it. And again, and then you realize that learning is a process, because you probably see the difference between your very first episode and where you are right now, like
yeah,
in your performance on how you interact with the camera or with your guest, right?
the whole process, yeah.
Exactly.
Yeah,
Yeah.
amazing. Okay. Uh, if you were to have lunch with one historical figure, who would it be and why?
I think that I think that I would choose Richard Feynman.
Richard Feynman.
Yeah.
Okay.
So for those who do not know, Richard Feynman was one of the physicists involved in the Manhattan Project.
Yes, Oppenheimer.
Yes, exactly. So actually, there's a very small scene in the movie where like Feynman shows up,
Hmm.
um, but he was a very interesting character. I mean, he's a very important figure in science and both history, in my opinion. And he had this catch about learning and knowledge as well. He loves to give like public lectures for the public to explain physics concepts, and later on his lecture notes even became books that you can buy nowadays
Mm.
in Amazon, for example. um, and he really had this understanding of how knowledge and curiosity can come together to result in great things, right?
Mm.
And I think actually this I may be mistaken on this, but I think that this concept that if you can't explain something such that a 5-year-old would understand means that you still didn't grasp it
Hmm.
fully, right? So for him, being able to say that you understand something equals being able to explain it as simplest as
Simple,
possible.
yeah.
Yeah.
It's only the experts who can explain it
Yes.
very simple.
Yeah.
Yeah. So Richard Feynman,
Yes. Yeah.
where would you take him? Where would you meet him?
I
What's
mean,
the setup?
uh, look, if he came to Saudi, if
Uh,
he was alive and he came to Saudi, I would probably take him to Thule.
okay.
Yeah.
Get him some fish.
Yeah. Or Yemeni
Okay.
food. Yeah.
You.
Since I got a car in Saudi, I go to Thule almost every day.
Mm.
Yeah. At least for a falafel or Yemeni or a juice.
Yeah, we have a selection of options.
Yeah.
It's not too much, but it's good to mix
Yeah, it's
in.
good. Yeah, exactly. Yeah, it's very nice. It is a more local community, I would say. Although like many workers that are also foreigner live in Toul. It is like a more traditional community. It's not. It has definitely a different dynamics from KAUST, and it's pretty interesting to see and to try to blend in. Right.
Okay.
By now, when I arrive to the Yemeni restaurant, I order in Arabic. I try to at least
Oh, you've been here for like 5 years now, so
for 6 years. Yeah, I mean,
you can say khalas, you can say what?
I can say halas, I can say shukran, I can say yalla,
Mm.
yalla habibi.
Yalla habibi. Yeah.
Yeah, so it's very nice. Yeah.
Mm. Okay. Uh, what is one misconception about your research that you would like to clarify for the public?
Yeah, I think there are actually like 2 points to this. The first one is not properly like a misconception. It's just like something that maybe people overlook, take for granted. Many people do not really appreciate the level of complexity that lies behind the fact that when you plug something on the wall, it
It
works,
works.
right? So I wouldn't be surprised if I asked someone, well, where does electricity come from? They say from the wall, right? Behind that, there is an immensity of investment, infrastructure, research, skilled people, workforce that are involved in this. And to keep all this running is very, very complicated. Um, I think that power systems, power networks can be characterized without exaggeration as the most complex like network system ever built by human beings. Because if we take Saudi is a pretty big country, but if we look how these things work in Brazil or Russia that are even bigger countries, or even the US, you can't even like start to grasp the level of complexity that lies behind that.
And it has to work 24/7,
24/7.
non-stop, very
Yes.
reliable.
Yes.
Because
Yeah.
there's a lot of, imagine if your computer just shuts off in the middle of the experiment.
Correct.
It's a very critical.
Yes, I mean this is true. Like, and also, of course, nowadays most hospitals or more critical loads, they have like their own backup generators and things like that. But even from the perspective of the normal user like you and me, right? If we lack electricity at our houses for like 5 minutes, we get very angry at it, right? So yes, of course, this is a huge work to keep everything running. And I think that connected to this overlook, to this misconception, is the fact that some people may ask themselves, okay, if a country has the money and has the space, why don't they make everything 100% renewable, right? And my research is trying to give like a little bit of a contribution in answering this, as seeing how far can we push this in a safe way. Because the truth is, we have been analyzing, understanding, and operating power systems for basically the same way for the past 100 plus years, right? And all of a sudden, we have this push to have renewable energies, and we have people putting solar panels in their houses and wind turbines that depend a lot on the wind speeds, the sun. So all these things are very new, and there are many problems that we didn't even expect to happen, and sometimes we see happening in modern power systems, right? So there is a lot of research, people rushing to try to get the answers, or sometimes even ask the questions to find the answers, right? Because there are so many things that we are trying to solve, because there are many technical challenges to come with this, and it's a big shift in the mindset from operating a traditional power system to a renewable power system.
Yeah, I know this. I know that when they started implementing electricity in the US, investors, like I think it was maybe Tesla or someone who was, or maybe Edison, who was, they were wiring the lines, and the public had concern about using 220, thinking it's too much. That's why in the US it's 110, right? Just because of the public
Yeah,
fear, right?
I'm not sure about that. I know that like these standards they change from country to country. Usually the standards regarding voltage amplitude and frequency, right? So we have 50 and 60 hertz are the ones that are usually gone for. What I know is that like it was the discussion about DC and AC, right? It was
Yeah.
the strongest discussion between Edison and Tesla. Nowadays, we have modern power systems that use both, right? At transmission level, at least, because basically what we found out is that okay, for very long distances, DC is easier to operate, has lower losses than AC. So Brazil, for example, has a couple very high power HVDC links. In Europe, they are installing a bunch of them in China, mainly to interconnect systems that are isolated, right? So this is very interesting because also like these voltage levels, these 110, 20, 20, we are talking about like what we see on the wall, like distribution level, consumer level voltages. But when we go for transmission lines, these transmission lines operate at several hundreds of thousands of volts, right?
I was just talking about the public perception because people were afraid of 220 for
Yeah.
some reason.
Yeah.
That's why they put it as well.
Yeah, that's what I told you. I don't know if that is actually the reason, but I would understand.
I remember reading it
Yeah,
like
yeah. But this is interesting. Yeah.
Yeah. Okay. What is one fact about you that is completely true, but it sounds like a lie?
Yeah, this one no one believes it ever.
What is it?
I never tried any cola soft drinks. Ever.
Cola.
Never tried.
Just
yeah.
cola?
Yeah, Coca-Cola, Pepsi, these things, right?
You never tried any soft drink?
No, I mean some soft drinks I tried or drink, but like cola based, which is like Pepsi and Coca-Cola, I never tried. I don't really know why, but my parents say that when I was a kid and I would go like to kids' birthday parties and things like that, and people would like pour like Coca-Cola for me, I would cry and ask for water instead. So, and I grew up like this. I think it's a streak that I want to keep.
I mean, that's good for you.
Yeah.
Good for your heart, good for your health.
Yeah. I mean, but yeah, this is something that I never even like felt like trying after that. So, yeah. But this is something that people usually say, oh, it's impossible. You're kidding.
Coca-Cola should contact you and video, watch you take the first sip and see how you transform.
I mean, for
into a Coke addict.
I mean, for the right amount of money, everything can be done, right? So,
yeah, just put a number on it. And,
yeah.
Watch your email from Coca. Okay. What is the most random thing you Google searched this week?
I mean, it's not a super random thing. It was just like a curiosity that came out of nowhere. I really wanted to understand how Shazam, the app that identifies music for you, works. I didn't quite Google it. I asked directly to ChatGPT, and it turns out that it is a very interesting concept that mixes up signal processing with information fingerprinting and efficient search algorithms in massive databases of music, right? So basically what they do is when you open your microphone with Shazam and capture a piece of music, Shazam does what is called the Fourier transform.
FFT?
Yes, so it does the Fourier transform, identifies peaks of the frequencies and the amplitudes, and transforms this information into a hash, basically like a string of numbers and letters.
So it gets a signature of the...
It gets the signature of that, which of course has a much less size in bytes than the whole audio piece, right? And they search for that hash in their databases of full songs that were transformed into a full hash, right? And then they try to see the matches and find the corresponding song. It's pretty interesting.
Oh, right. So you can, I mean, it makes sense to me now. I understand how it works.
Yeah.
Thank you for letting me know.
Welcome. I was pretty surprised as well. I said, man, how do they take the sound itself and try to match. No, it's a much like
They have to match
much
the
more
hash. Yeah.
They match the hash.
Yeah. Okay. Makes sense.
Yeah, which for sure is much easier than matching the sound information itself.
Yeah, because you're matching characters
Frequency,
now.
yeah, characters. So you go from the audio, so time domain information, to frequency domain,
yeah.
and then you transform that into a hash that it's just letters and numbers. Yeah.
Okay. Not so random. It's
Yeah.
very prevalent. You listen
Yeah.
to a song and you like it. You're like, what is
Yeah,
that? Thank God
exactly.
for
Yeah,
for Shazam.
yeah. It's very good, especially here in Saudi, right? Sometimes I listen to a song, I can't tell what they're saying,
Oh, that's
because
Arabic.
if yeah, for example, if I listen to an English song, I can capture a piece of the lyrics and try to search for it. Here it's much harder, so I have like Shazam ready on my phone and just yeah.
Cool. Okay. This is gonna be a shift now. We're gonna dig deeper
Okay.
into you. What is your toxic trait?
So my toxic trait is one that people get very angry with me about, but I always think that I'm right about it. Is I am obsessed with punctuality.
Being on time.
Being on time. Being on time is like essential for us to have like a relationship, a friendship. You need to be punctual. Like even if I say, Taib, let's have dinner at my house at 7 p.m. Like if it's like 6:59, you're not ringing at my door, I start getting anxious and I say, man, where are you? And the same goes for me, by the way. If I feel that I'm going to be late for anything that I scheduled a time with anyone, I start getting anxious. Oh my God, I'm gonna be late. I'm gonna be late. So yeah. So if we schedule something, expect me to be on time and expect me to judge you if you're not on time.
Yeah, I mean, I guess you suffered a little bit with the Arab timing here. Sometimes
Yeah, but I mean,
the Arab timing is very forgiving.
Yeah, but Arabs are not the only ones, right? In Brazil, being on time is not very much in the culture. I think this is really a personal thing. I don't know. Yeah.
Okay. Punctuality.
Yes.
It's
Always be
not
punctual,
that bad.
people.
It's
Be
not that
punctual.
bad.
Yeah.
Okay. If someone were to narrate your life,
Okay.
who would it be and why?
Oh, look. I think there are only like two possible answers to this question, and one is Morgan Freeman,
Morgan Freeman,
obviously,
classic.
and Sir David Attenborough.
David Attenborough.
Yeah. I mean, you can. I think that these voices are very known for narrating anything, and I can totally see myself like in a third person view, right? And either Morgan Freeman with his characteristic voice, or Sir David Attenborough talking about me as if I was like some creature in the wild.
Just like operating.
Yes, trying to like solve research problems and things like that. It would be fantastic. Yeah,
Mr. Otavio Bertozzi is in building 5 again.
Yes. Yes, exactly. Yeah, like my natural habitat.
Yeah, natural habitat. Yeah. Yesterday, my professor Eric Ferron told me that you're going to be the Arab David Attenborough. He told me you have the voice for it. Just use it.
That's actually pretty good. Yeah, you have a very good radio voice, I would say. Yeah,
a lot of people told me that. And I'm like,
no, this is
I'm gonna
very
make
good.
a podcast, not a radio, guys.
No, this is very good. This is very good. I mean, I know, I actually know a bunch of people that work like in radio stations, mainly from my hometown, and some of them, they do not have like a natural radio voice like you do, and they actually have to train. So like they talking to them like outside the studio, they may have like my voice, but then when they are on the microphone, they have your voice. It's like it's kind of it's funny. Yeah.
I'm a little bit sick now, so maybe it's affecting, but
Yeah. No.
Stay sick.
No, it's good.
Okay. What is your go-to karaoke song?
Mr. Brightside by the
Mr.
Killers.
Brightside.
Yeah. So I'm actually a big karaoke fan. People, if you want, you can invite me. So when
It's like you have the black belt or not yet?
No, no, I don't. So so basically, what I used to do when I lived in Budapest for a year during my undergrad, I did this exchange for a year in Budapest, and there was this like karaoke place that I would go almost every week with my friends,
Hmm.
and I would sing at least once. Mr. Brightside was kind of funny. Yeah,
Turning saints into the sea.
exactly. Yeah. What
Yeah.
is yours, by the way?
What is mine? Um, Karaoke.
Yeah.
Um, I would like to sing for someone called Sabah Fakhri.
Okay.
So he's a Syrian singer,
Okay.
but it's Arabic.
Okay.
So
Nice.
he has a very deep classical voice. Everyone knows him.
Uh huh.
Yeah. So that's my go-to.
That's nice. That's nice. You need to suggest me some songs by him.
Yeah.
I like exploring. Yeah.
I'll send you some links and let me
Yeah.
see if you vibe with it.
Yeah. Please do. Yeah.
Yeah. Cool. Okay. Well, it was awesome to have you, Otavio. Uh, good luck with finishing your PhD,
Thank you.
and thank you for coming on the podcast.
Yeah. Yeah. Thank you. Thank you so much again for the invitation. It was a very nice talk. I
Yeah.
think that it's a great project, and I mean you are in the right place, right? KAUST has a bunch of very interesting people working in the
100%.
most interesting topics.
Yeah.
So this has everything to be a great success, and keep up with the project.
Thank you.
Thanks, man.
Thank you very much. Thank you, guys.
Thanks.
Thank you guys for watching today's episode. If you guys like the series, please like, share, and subscribe. And let me know if you want to suggest anyone interesting on campus that you want me to interview. And as always, stay strong. And if you haven't watched the previous episode, it will be here or here. Thank you, guys. Cheers.